Ladies and gentlemen, we are back once more to more Kerbal Space Program. We are going to conduct a new mission today, and that mission is going to send us to a new world, the moon beyond the moon. It is called Minmus, and you may notice that there's something already there actually. That would be a new space probe that I've designed. Now, what does that space probe look like? Let me show you actually. So, let me introduce to you the Mariner prototype. And don't worry, I will simultaneously be sending a manned mission to Minbus to help save time, but let me show you what we can do now that we have a few more technologies on our tree. So, I'm going to be sending this unmanned probe, or I already have, I've put it in orbit, around Minbus. Now, this doesn't really look too impressive, I take it from the way it looks right now. It's got some landers on it, which implies that it's going to land on the surface. We've got some RCS thrusters right here, which means that we'll be able to do some flying tuning. Maybe we'll be able to land in multiple locations. We have the standard science along here. We have our barometer. In case that place has any atmosphere, we've got our thermometer. We have this new device here called a seismometer. I have two of each of these just in case anything weird happens and one of them doesn't work. This device is going to have these brand new heavy batteries. They have 400 times recharge, whereas these ones up here only have 100 times, so they're a lot more potent. It is designed to be able to both orbit and land on the moon. If we have enough fuel in these thrusters down here, it will be able to land multiple times. Now, here's where it gets fun. So, let's say we've landed on the moon, or we've placed ourselves in an orbit. That's all fine and dandy, but we want to be able to make sure that this has power, and you may have noticed that this doesn't have any of our older solar panels on it. That is because we've recently installed some brand new solar panels that we got from our Advanced Electrics tree in the technology tree, the science tree, if you will. These are foldable solar panels. Let me show you what they look like. Now that's nifty. We have applied 6 solar panels onto this. It provides a lot more power than our older ones did, and if we need to, we can retract them back on board. Now, the reason why this is a useful system is because there are essentially now 6 solar panels folded into a single slot here, which means that we have more room to place other things instead of the solar panels. In fact, these solar panels also offer another interesting ability too. Now, you might think that it's going to be a little bit annoying because they're all facing the same direction, which is up. But, in fact, these solar panels have a very unique ability. If I zoom out here, let's see if we can see where the sun is right now. You'll notice that it is also, well, it's supposed to be straight up, actually. I see something in the distance. What is that way up there? Interesting. But, watch what happens when I speed up time. Take a look at the solar panels and watch. Do you see that? They are slowly changing position. And what that means is that they are actually following the sun. So not only do they take up less room, but they also automatically track the sun, which will be very useful so that we don't have to keep positioning our craft. That way we can position it however we need to, especially if we're performing a landing. Although if you are performing a landing within an atmosphere, it's probably a good idea to have these retracted so that when we launch, they don't accidentally blow away, because the trade-off to them being more efficient is that they're also more fragile. By the way, in case you were wondering, this is the title of these particular solar panels. Last but not least, we need a very good way to transmit all the data that we currently have on our ship, and we've also installed a brand new communicator. It's the cylinder up here on the top. Now, that might not look all that impressive from the outside, but let's suppose we were going to transmit some data. Let me show you what it looks like if we were preparing ourselves to do a transmit. Oh, I love that innovation. That is so cool. So we have a much more powerful antenna built into our space probe. So this is what the whole probe looks like from the outside. And needless to say, it is scores above what our older probes were capable of doing. For landing, just like when we were on the moon, I have installed two lights on either side. They will help us track where our landing feet are going to be, so they'll help us position ourselves if we land in a darker area of the of Minmus, the moon. And that's more or less everything that this spacecraft is capable of doing right now. Bear in mind that this is a prototype device, so the idea is to see how well the system works on Minmus, and then once we have it really nail down the flaws and improve upon the design, then we'll send it even further onto interplanetary missions and send them to new planets so they can do science there, which will help us send manned missions to other planets and back. So this right here is a very important step and an important test run of our future interplanetary missions. Let me show you what the whole launch system for this looks like, and then I'll show you what the manned mission to Minmus looks like. So let me just reopen the Mariner prototype here. So this is our launch system. It actually uses a very similar system to what we used to get to the other moon. It uses the exact same launch system. So everything down to about this level is capable of is really capable of launching us to Minmus. In fact, as you'll see later on, it's actually easier to get to Minmus than it is to get to the moon. So I guess if you were trying to play the game in career mode and trying to be efficient about it, that might actually have been a better step. The upper stage of the system carries not one, but two of these fuel tanks. And I wanted to make sure that we had plenty of power to load this system. A little bit higher up, above the decoupler, are two Science Juniors and two Goof experiments. They're not attached to the final satellite right here, which is what I was showing you before. This upper stage is what's actually going to land on the moon. These are atmospheric, so I'm going to be doing these in orbit, and just before we hit the surface of the Kerbin area, Minmus. They will be transmitted by this satellite dish up here, and because of the fact that they are not designed to be a part of the landing system, they will be ditched prior to actually landing on the surface to conduct our three smaller experiments. Right now, I already have one of these orbiting Minmus, and you might be wondering why I skipped right to that. Well, let me show you our lander that we're going to be setting there. Our Kerbin lander. It is similar to the one we're using for the unmanned probe, but up to this and beyond, we have a much more science-heavy system. For example, we have three Science Juniors here, not two, but three, and that is because this is going to be designed to take measurements right in orbit on the surface. And if we have an opportunity to do a double landing where we pick it up and put it somewhere else on Minmus, we'll do a third science test. And each science test also has a GOO experiment associated with it as well. Like the space probe, this also comes equipped with the three main small devices that we have right now: the thermometer, the barometer, and the seismometer. We are using the advanced solar panels connected to the main science unit right here, and above we have the same model we used to leave the moon. We have this stage with the RCS thrusters and the smaller solar panels along with the parachute. I am a lot more confident in this system's ability to make it to the Minmus and back, and that's because Minmus is actually much smaller than the moon is, and because it's smaller, it also has a lot less gravity. In fact, I'm pretty confident that we could actually use the RCS thrusters alone to get us from Minmus back here to home. But we'll see how that works in practice. So, We're going to launch this mission to join its unmanned brother up in space. The reason I didn't show the unmanned brother, get to where it is in Minmus is because it's going to use the same exact procedure as I'm about to show you with this manned mission. So we'll get right to it. And we're back, everyone. I took the liberty of putting ourselves in Kerbal orbit because we've already seen how to launch the system before. So I'm going to cut straight to getting us to the Minmus system. First of all, I need to kill that maneuver. That's the one I use to get us into orbit. Now, Minmus is all the way over here. And you might think that it's a little bit more challenging to get there than it is to the moon. Well, slightly. It's not too more challenging. You'll note, if you recall, whenever we thrust to get to the moon, you notice that our archway would very slowly start up, but then gradually move faster and faster and faster the more we accelerated. So, frankly, we only really need just a little bit more thrust to actually put us there. And once we get there, we will only need a very little amount to actually put us in orbit. So, that's all good. Now then, we actually need to get to Minmus. So what I'll do is I'm going to click it and set it as a target. You notice when I did that it created an ascending and descending node. Well, I believe the way this works is that if we click the node and then tug on this, we can actually pick the optimal way. Oops, no, I'm sorry, I'm supposed to be clicking this, of course. We can click the optimal way to get there. You'll notice that as it goes up, our app oasis and our descending node go up as well. And if I keep doing that, then these new nodes show up, called closest approach and position at closest approach. What that means is that I will put myself in the orbit, but at my closest approach over to the right side of the screen, Minmus will be all the way over to the left where it says target approach. So if we reposition the orbit so that these two sort of slide together, if I can get these two to come together, then we'll be able to reach the target, which in this case will be Minmus. That should work for most systems, actually. First, what I want to do is try to see how the orbit is slightly tilted compared to ours and to the regular moons. If we use these purple parts of the maneuver node right here, we can actually tilt the orbit. And if we do so until they match, it'll actually be a little bit easier to get ourselves into an orbit. Plus, if I grab this and spin it, maybe increase that. No, because if we go too fast, then we're just going to escape Kerbin altogether. So maybe if I pull on this right here, slowly turn the... Oh, looks like that would get us to the moon, actually. Interesting. So that would create its own problems. I could, I guess, in theory, go to the moon and then launch from there to go to Minmus, but the moon is an orbiting place, and it might make it a little bit more challenging. Plus, we don't need to do that. It would be... Plus, if we try to do it in this way, it would actually send us in an upward orbit, which would be very, very difficult to get to the moon from there, or to Minmus. So I'm going to pull this forward a little bit, see how our nodes are closer than before. Really what I want to do is try to adjust this until we get to a suitable or really acceptable approach. Oh, hold on. Look at that. Maybe I can get them really close. Minmus encounter. Okay, so I can definitely put us in an encounter at least. 2 million miles. I'm going to try this, actually. I'm going to try to see this. There's no periapsis for Minmus, because I think the reason why is because I'm putting myself into a moon periapsis, and it wants to do one step at a time. So it's a little bit awkward, but I'm going to give this a shot and see how well this works. This will be our first... this will be a first time really doing this. This is a technique that actually some astronauts use in the real world, or some space agencies use in the real world. It's called a gravity assist maneuver. It's using the gravity of one target and performing a flyby of it instead of getting caught in its sphere of influence, if we pass by the moon in a certain way, its gravity will actually slingshot us away from the moon and actually throw us towards Minmus. So in theory, if I do this right, it might actually be less cost. It might be a little bit more cost effective to just do it this way. But that's for the numbers to decide. So I'm going to save before doing any of this. It says it only takes 48 seconds, and the reason why is because we still have this big giant booster behind us. So we don't need to use nearly as much. I mean, we still have our normal stage after this too. Now, the general rule of going from one area to another still persists, where we want to sort of burn about halfway. So see how our estimated burn time is 48 seconds? So I want to set it so that 24 of those seconds is spent before the node at the bottom, the T minus 1 minute 54 seconds before, rather that should be 24 seconds before that countdown goes, and then it should end 20 seconds after the countdown mark is. If we spread it out nice and even, it should give us the orbit that we want. But that's for the practice of this go. That's how that'll be determined. So any second now, I'm going to fire up the thrusters. In fact, I'm going to go over to our orbital map here and see how it looks from the outside. I'm going to start the burn at 24 seconds. We want a Minmus encounter here. The nice thing about this is that once we pass by the moon, we don't have to actually do anything. The moon's gravity will push us in the towards the Minmus for us. If you're playing the game, this is if you're playing Kerbal Space Program and you're trying to get to Minmus, you're probably not going to have this happen to you. This is actually kind of rare to occur, I have to say. I'm rather surprised that this is working out the way it is. Oh, there goes our first stage. There we go. And just like before, that stage, that booster is going to remain in the orbit that we had it set in. So this sort of strange elliptical orbit will slow down. Okay. Gonna go nice and slow as we approach. I'm gonna wait for this to put us right where we want to put it. Start looking out over there. And we are going to cut. Aha! There's our Minmus encounter. So, that puts us in altitude at Minmus at 612. That's not the best way to do it. I think we can readjust our orbit once we get there, but I am actually really pleasantly surprised that I have a chance to show you the idea of gravity assisting. We might actually be using that to get to other planets in the future, especially the ones in the outer solar system, where they require a lot more fuel. So if we boost from one planet to another, we should, in theory, be able to get us a very, very efficient system to get to other places. Now, the problem with that is that it also means that we have to wait for the planets to align in the correct way. This is sort of a freak accident. I didn't really plan for this, although it is kind of cool to have happen. Normally, when you're going to Minmus, you would just take a direct route. So we are going to make our way over to Minmus. In fact, I am just going to go into this view right here, because it is worth looking at things in the real-world approach. The real world is not graphs and numbers, it is worlds, stars, and space adventures. Let's speed this up a little bit. There it goes, spinning away. Meanwhile, the moon gets ever closer. I'm going to slow us down just a little bit so we can appreciate the moon as we sail past it. We were able to perform a successful landing there just fairly recently, if you recall. We have 3 lifeboats that are still over there right now in orbit around the moon. We might be a little bit too far away to see them at this point, but they're still there, remaining ever diligent, just in case we ever have to go back. Anyway, let's take a look at our... Oh! I see that. That's a moon escape. When we hit that moon escape node, we should then jump over to the... See how when I mouse over... You can't really see my clicker, but when I mouse over the moon escape image right here, the other circle appears at the bottom of that orange orbit line. That's because we're going to jump from this blue line right here over to the orange one, and that'll put us on a trip to Minmus with a periapsis, or our closest approach, at it looks like that one's at 776. So it's not exactly as we had planned it, but we can adjust as we get closer. There we go. And up there are our lifeboats. Okay, so pretty shortly we're going to be arriving in the moon's sphere of Minbus's sphere of influence. I can add a maneuver if I wanted to, and perform a retrograde orbit burn right here. But it's actually a little bit tricky to do, I will confess, and if we do it too early, it might actually push us away from the moon. So I'm actually going to wait for us to get closer. And then I'll put ourselves into a lower orbit where we will be able to scope out a landing site and rejoin our Mariner prototype. Anyway, once we pass this blue Minmus encounter node, we are going to be entering its sphere of influence. So any second now, I'm going to hit the stop, or not stop, but I'm going to slow us down to 1 normal speed. And I'm going to mouse over our periaps sign right here and perform a retrograde, wow, that was way too fast, a retrograde orbit, and push our periaps down to about 10 kilometers. Minmus is much smaller, and its mountainscapes are much less significant. So, in fact, if we go as low as 10, we'll still be safe. I probably wouldn't go any lower than 10, though, if only because it is a bit risky. If we go lower than 10, it still wouldn't quite hit the surface, but you run the risk of hitting tall mountains. So 10, I hear, is a good number. I'm just trying to get it to about 10. 11's there. That's probably acceptable. So let us perform the maneuver, and then when we do, we should have a safe landing there. I don't quite see Minmus yet, I have to say. Oh, there it is. It's way up there. When we get closer, you'll be able to see surface features. It's nothing quite like our normal Earth moon. I don't think there's any place in our ordinary solar system that's quite like we're about to go. So our next burn is going to take place in 1 hour, but we are going to speed up time because I'm pretty sure you guys don't want to have me wait an hour for us to get there. In fact, we're going to speed up time a little bit more. More! You can see some mountain ridges and terrain showing up there now. And I'm going to make sure that we stay on top of our boost because we need to make sure that we successfully do this. If this doesn't work, we will actually either put ourselves back in a Kerbin orbit, or worse, throw ourselves into deep space. And deep space might be kind of cool, especially with the amount of fuel that we have, but I'd rather not risk losing Jebediah Kerman. Keep pronouncing it like it has an I. I'm not sure if you can hear those Skype noises, by the way. I apologize if you can hear them. The Mandus crew is doing their usual business. Okay. Nearly at the node. Since we're putting ourselves into an orbit, we can just hit it right on the T marker a couple seconds before. In fact, I'm going to start the burn now. And let's take a look at our orbiting map right here. We want to make sure that we get a periapsis of about 10 or so. So, slowly, ever so slowly. Right, so now we're at the stage where we would be going back into Kerbin orbit, but that's not quite what we're aiming for. 10, 9. Okay, slowing down on the thrust here. Slowing down, slowing down. Want to make sure that we are on top of this. We don't want to approach it too fast, because if we miss, we might actually put ourselves in a collision course. And while we could survive a collision by thrusting retrograde when we get close enough to the surface, that wouldn't give us the ability to choose where we want to land. Plus, this is a much safer approach. Almost. And, there. Good! Alright, so we now have a periapse, which will put us close to Minmus. We are now officially in orbit, but if we put ourselves in a very low orbit, it'll give us plenty of space for us to choose where precisely we want to land. So I'm going to create another maneuver and do the same which what we did here, put ourselves in another retrograde orbit, until that is also at about 10 or so. Well, 15. It doesn't have to be perfect. Low is good enough, really. Here we are. And again, this is going to be another 5-hour burn. But this time, let us take a look. We can actually see the moon slowly... I'm not sure if the moon is rotating or if we're going so fast that it looks like it's rotating. I think I see it rotating, though. Yeah, I think it's very slowly rotating. I think it rotates on its axis. That's not usual for a moon. The moon's actually sort of green almost. Greenish-blue. A very dull greenish-blue. The characters in the game think that it looks sort of like a mint giant piece of cereal. And, they might have a point. Okay. Getting ever closer now. Oh, look at that. It's rendering, and that means we're really close. So right away, we can already see some interesting places to land. I'm going to start doing some science experiments up here, by the way. Look at that. We're high over Minmus, and in fact, if I keep the data, we'll already get 100 science. That's a huge amount of science to get just from one simple experiment. And we have many, many science experiments with us. I'm also going to observe the mystery goo, which gives us an additional 40. Also, we can do a thermometer experiment. I don't believe we can do barometer or seismometers yet because we're not on the surface. Oh, we cannot do a thermometer experiment. We might not be close enough to the surface for it to count. So, we're going to get even closer. Once we approach the node and get closer to maybe 10 kilometers to the surface, we might be able to conduct more science. Let's see. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, slowing down. We are very low now, so I'm going to try to conduct some more science. This time with the thermometer. Where did that thermometer go? There it is. Oh, maybe I can't power it. I'll try it a little bit later. Maybe the seismic data can give us some results? Nope. But we can try to do some other observe materials at a higher altitude like this. Now we're in space near Minmus, not high above Minmus. That actually gives us an additional 100 science. Again, just being here gave us that amount of science. An additional 40 science just from being near Minmus from the goo. Is the thermometer going to cooperate, or do we have to get lower than 10 kilometers? Maybe we'll do that. Anyway, we're about to do the burn, so let's quickly readjust ourselves here. And commit to the burn. And burn. Coming in slow. Nice and slow. Don't want to go too fast as we approach, because if we go too fast, we'll put ourselves again on a collision course, and we don't want that. There's the Mariner probe, which will be joining very soon, in its prime. I want to make sure our periapsis does not dip below 10. There. And our apoapsis is 15, so that's almost what we wanted exactly. Okay, so we are now in a successful low orbit around the planet. So, we are very close to landing on Minmus, and we will be doing so, but in the next episode, that's when we'll be able to explore this new moon, and pretty soon land on it and return home. We already have almost 300 science and we haven't even landed yet. So, needless to say, we're going to have a windfall of experiments ready for us to go when we get there. Until then, everyone, this is Ardwick. Stay tuned, and good night.